So normal distribution. This is a continuous probability distribution. We have three distributions we are discussing now: binomial, Poisson, normal. Binomial Poisson distributions are discrete probability distribution, but this one is different. This is continuous distribution. Continuous distribution means a continuous random variable x, a continuous random variable x is said to follow normal distribution. Normal distribution if it has the density function. If it has the density function. So for continuous distribution we have density instead of probability function. In the case of binomial and Poisson you will have p of x, but here we have small f of x. F of x equal to 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. Or in few books you will find in the place of mu b. In the place of mu b you will have b also correct. Where x is from minus infinity to plus infinity, mu is also greater than 0, mean, and sigma greater than 0, positive values, and where mu is called mean, where mu is mean, sigma is standard deviation. We call that one as SD. So 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. So here mu and sigma are mean and standard deviations. This is the density function for normal distribution. So if you want to find mean, variance, median, anything, we will use this one, small f of x. If you integrate this f of x, you can find probabilities between any two values. If you want to find mean, you need to integrate this density function. So to find any application for normal distribution, you have to use the density function. Using this density function, if you draw a graph, we call that one as normal distribution graph, normal distribution curve. Sometimes it may call normal curve. It is bell-shaped curve which never enter into the x-axis. Which never enter into the x-axis. It has a maximum value at x equal to mu. So this is extended from minus infinity to plus infinity. The shape of normal distribution curve is bell-shaped. It is extended from minus infinity to infinity. It never enter into x-axis. It has a unique mode, maximum value at x equal to mu. So this one we will call it as x equal to z equal to 0 line. Because in normal distribution we take z as x minus mu by sigma. So if you write in the place of x mu, what you will get? You will get z value 0. Z equal to 0 line. And we call this one as z line. Like x-axis line. Okay. This is about normal distribution. We are going to find probabilities under this normal curve. the total area under normal curve is 1. If you want to calculate any probability, that should be lies between 0 and 1. That you can get under normal curve. By drawing this normal curve, one can evaluate probabilities in normal distribution. Okay? Any doubts you may ask on normal distribution? Show that mean, median, mode of normal distribution coincides. It means in normal distribution, mean equal to median equal to mode. That we need to prove. We know how to find mean in normal distribution because normal distribution is continuous probability distribution. In continuous probability distribution, to find mean, before that first I am writing in normal distribution what is f of x. In normal distribution, we know the density function small f of x equal to 1 by sigma root 2 pi e to the power of minus 1 by 2 into x minus mu by sigma whole square. Minus 1 by 2 into x minus mu by sigma whole square. Now, this is the density function for normal distribution. Using this density function, we are going to evaluate mean, median, mode. So first coming to mean. Mean equal to integral minus infinity to infinity x into f of x dx. This is formula for mean. Mean formula in continuous probability distribution. So what is small f of x in normal distribution? That I am going to write. X into small f of x is this one. 1 by sigma root 2 pi e to the power of minus 1 by 2 into x minus mu by sigma whole square dx. Now 1 by sigma root 2 pi is constant. The remaining value we will write next. Before writing that, what I am saying, to evaluate any value in normal distribution, we take x minus mu by sigma as z. That's why we also call normal distribution as z distribution. So now differentiating, what you will get, dx by sigma is equal to dz. What is dx? Dx equal to sigma dz. Now from this, what is x? We need to write in the place of x z value in terms of z, x in terms of z. Sigma z plus mu. If you take sigma to here, that will become sigma z. If you take minus mu to this side, plus mu. Sigma z plus mu is x, and dx by sigma is dz, dx is sigma d, sigma dz. Whenever if you take like this substitution to evaluate an integrand, you need to check whether the limits changes or not. If limits changes, you need to write new limits. If limits won't change, you can follow with the same limits. See here, because limits are infinity and minus infinity, if you write in the place of x infinity, infinity minus anything infinity, infinity by anything infinity. So limits won't change. Limits are same. We are going to evaluate with the same limits. Limits are same. So now I am going to substitute here these substitutions. In the place of x minus mu by sigma z, I am going to write, I am keeping this 1 by sigma root 2 pi as constant. Integral minus infinity to infinity. In the place of x, we are writing sigma z plus mu e to the power of x minus mu by sigma is z. Right in the place of x minus mu by sigma z minus z square by 2 dx. What is dx? Dx is sigma dz. Right in the place of x minus mu by sigma z, Write in the place of x sigma z plus mu. Write in the place of dx sigma dz. Now what happens? This sigma get cancelled. Now we can split this one into two integrals by multiplying the sigma z and mu with this. Then what happens? 1 by root 2 pi integral minus infinity to infinity sigma z e to the power of minus z square by 2 dz, sigma z into this one, plus integral minus infinity to infinity. Mu is constant, we can write here also if you want you can keep sigma constant. Integral minus infinity to infinity e to the power of minus z square by 2 dz. Just we splitted this integral into two integrals by multiplying with sigma z with this and mu with this. Now whenever if you have integral minus a to a, integral minus a to a, then we need to check this integrand as even or odd to apply this formula. This famous integration formula we all know. Integral minus a to a f of x dx equal to 0 if f of x is odd function, to integral 0 to a f of x dx if f of x is even function. We know that. So here odd and even. So a function is said to be odd, f of x is said to be odd function if f of minus x equal to plus f of x. Odd function minus f of x. Even function, if f of minus x equal to plus f of x, then we call that function as even function, like this. Even means f of minus x is plus f of x. Odd is f of minus x is minus f of x. So without using this formula, there is simple technique to identify whether the function is even or odd. Z, here the function is in terms of z. So z power odd number, z power 1 odd function, z cube odd function, z square even function, z power 4 even function. Like this one can easily identify the function is even or odd without applying actual formulas. Coming to here you are having z. Z is odd function, z square is even function. So whenever one odd and even are product, to decide that product is even or odd, again we can use one small technique. What I said, for odd function f of minus x will be minus f of x. For even function f of minus x is plus f of x. So what I am saying, keep this technique in your mind to decide this function is even or odd. If it is odd, I am treating that one with minus sign. If it is even, I am treating that one with plus sign. If you multiply these two, if you get answer minus, that will be odd function. If you get answer plus, that will be even. Minus into plus, you will get minus. So what we can decide about first integral? This will be odd function. This is the very easiest way to decide the function is even or odd whenever two functions are in product. Here this is odd function, this is even. I said how to decide even or odd. So minus into plus minus, this is odd. So if the function is odd, what happens? That integral value is 0. So this complete integral value is 0. No need to evaluate this one. Now coming to this. Here we are having only one function. In that function z we are having. If z power is even, that is even. Z power is odd, odd. So see here, z power is even, z square. So this is even function. So if it is even, we have to apply this formula. So first integral completely 0. What is left over now? 1 by root 2 pi. Sigma is there. I am writing sigma as constant. So this is 0, right? Sorry. This is 0. Here mu you are having. Mu mu is constant. This integral limits will be like this, 2 integral 0 to a, minus a to a becomes 2 integral 0 to a, minus infinity to infinity becomes 2 integral 0 to infinity. So what is left over term next? E power minus z square by 2 dz. So we all know that from complex analysis using beta gamma function technique, that is not our topic now. You can simply remember this formula. Integral 0 to infinity e power minus z square by 2 dz is equal to root pi by 2. That is that value. We can take that value directly. That is using gamma function. Gamma function means this one, integral 0 to infinity e power minus x into x power n minus 1 dx. From this we can derive that one very easily, but that is not our topic. So simply remember this value is root pi by 2. So if you write that value root pi by 2, what happens? Mu by, I am writing this one like this, root 2 into root pi. This root of pi by 2 I am writing, this 2 is there. Root of pi by 2 I am writing like root pi by root 2. Then what happens? Root pi get cancelled. Root 2 into root 2, 2. Root 2 into root 2, 2. 2 get cancelled. Root 2 into root 2 is 2. This 2 get cancelled. What is left over? Mu. So mean is mu. Okay. So the mean of normal distribution is mu. Now what next we need to prove? Next we need to prove median also mu, mode also mu. So coming to the next, so mean is mu. Next we need to prove that median, mode also mu. Mean, median, mode coincide means the three values are equal. So next we need to prove the median also mu. So first, before finding median, what is median? So median means it is a value which divides the total data into two equal parts. See, median is m, then that m divides the total data. Let median equal to m. If median is m, then what happens? Integral minus infinity to m f of x dx value and integral m to infinity f of x dx value will be half, because the total data value in probability is 1, half of the data is 1 by 2. So now here m indicates median which divides the total data into 1 by 2. Now I am taking one value from these two integrals. Integral minus infinity to m f of x dx is 1 by 2, and also integral m to infinity f of x dx also 1 by 2. These are two integrals. If you take m as median, if m is median, then I am taking this integral. Consider this integral. Consider integral minus infinity to m f of x dx. If you take this part, what happens? Again, if you split this one into two integrals by taking in between mean mu as one value. What I am saying? Integral minus infinity to mu f of x dx plus integral mu to m f of x dx equal to 1 by 2. This integral I am taking first integral. In the first integral I introduced one value mu. This one, you know, in integral, one of the property of integration, definite integration, integral a to b f of x dx can be written like this. Integral a to c f of x dx plus integral c to b f of x dx. That property I am using here. Integral minus infinity to mu f of x dx plus integral mu to m f of x dx equal to 1 by 2. Now we are taking this part from this integral by treating this one as equation 1. Again I am taking this part, consider integral minus infinity to mu f of x dx. So we all know f of x in normal distribution, I written here 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. Now I am going to write in the place of f of x this value. If you write in the place of f of x that value, integral minus infinity to mu f of x is 1 by sigma root 2 pi e to the power of minus 1 by 2 into x minus mu by sigma whole square dx. Limits are minus infinity to mu. Now to evaluate this integral in normal distribution, generally we take a standard substitution, that is x minus mu by sigma as z, I said earlier. Because we take x minus mu by sigma equal to z for every derivation, we call the normal distribution as z distribution also. Now differentiation of x dx, differentiation of mu 0, dx by sigma is dz, dx equal to sigma dz. This we did for mean, the same one. But coming to the limits, because we took one new substitution here, we need to check whether the limits are same or different. Coming to the limits, if you write in the place of x mu, what is z value? If you write in the place of x mu, when x equal to mu, what is z? So z is x minus mu by sigma. If you write in the place of x mu, mu minus mu 0, 0 by anything 0. So limit will be 0 here, z limit. Coming to infinity, generally infinity won't change, x minus infinity, then z also infinity, because infinity minus anything infinity, infinity plus infinity, anything infinity by anything infinity. So if you have infinity, no need to check, simply write that infinity. If you have plus infinity, limit will be infinity. If you have minus infinity, you will get minus infinity. So now with the new limits, with new substitution, I am evaluating integral minus infinity to mu f of x dx value. 1 by sigma root 2 pi is constant, 1 by sigma root 2 pi. Integral minus infinity to 0, minus infinity to 0, mu is 0, e to the power of minus z square by 2, dx is sigma dz, sigma dz, sigma get cancelled. So what is left over you are having? 1 by root 2 pi, integral minus infinity to 0, e power minus z square by 2 dz you are having. The remaining sigma get cancelled there. So already I written integral 0 to infinity or 0 to minus infinity e power minus x e power minus z square by 2 dz is root pi by 2. So that value if you substitute here, what happens? 1 by root 2 into root pi by root 2. So what you will get? Root pi get cancelled. Root 2 into root 2, 2. 1 by 2. Root 2 into root 2, 2. So its value is integral minus infinity to mu f of x dx value is 1 by 2. So from first equation, if you substitute that value here, what happens? This value is 1 by 2. 1 by 2 plus integral mu to m f of x dx equal to 1 by 2. Send this 1 by 2 to RHS. What happens? Integral mu to m f of x dx equal to 1 by 2 minus 1 by 2, 0. Now, in integration, if integral a to b f of x dx is 0, then the limits are same. A equal to B. Using that principle, integral mu to m f of x dx is 0 means m equal to mu. What is m actually? Initially we assumed m is median. Now we proved that median is mu. Any doubts, ma'am? Next we need to prove that mode also mu. Mode means, what is actually mode? Mode is value of x for which f of x is maximum. So that means we need to find maximum value of f of x. Whenever f of x is single variable function, in earlier classes we learned how to find maximum value. That you know, that procedure I am giving here. If f of x is given, finding maxima or minima of a function f of x. So to find maximum value of a function in single variable, first to find f dash of x and equate f dash of x to 0. Find x values. Next to find f double dash of x. Substitute this x value in f double dash of x. If at x, f double dash of x is less than 0, then x is maximum. Find f dash of x. If f dash of x 0, equating f dash of x to 0, find x value. Next substitute that x value in f double dash of x. If you prove that f double dash of x is less than 0 at x, then that x value is maximum of f of x. This procedure we are going to follow to prove mode is mu. So for that, first in normal distribution we know f of x. This is f of x. Now we need to find f dash of x. We all know that in differentiation of e power x is e power x. We know that. So you will get this term as it is first. Minus 1 by 2 into x minus mu by sigma whole square, because this is constant. Next differentiate internal term, this one. Keeping minus 1 by 2 constant. Treating this one as x square. Differentiation of x square 2x. 2 into x minus mu by sigma. Again differentiate internal term. Differentiation of x 1. So 1 by sigma you will get. This is complete integration part. First, differentiation of e power x is e power x. Next internal differentiation. Treating this one as x square. Differentiation of x square 2x. 2 into x minus mu by sigma. Again differentiate internal term. Differentiation of x is 1 by sigma. Now this 2 get cancelled. Okay. Now this can be written as, how we can write this? This is total value I written here. This is treated as f of x. So f of x. This minus I am writing here. What is left over? X minus mu by, here 1 sigma, here 1 sigma, here 1 sigma. X minus mu by sigma cube you will have. Okay. X minus mu by sigma, sorry, this one is f of x, right? So sigma into sigma. X minus mu by sigma square. So this is f dash of x. Sigma into sigma square. Now we need to equate this one to 0. Equate this one to 0. F dash of x 0. That is minus f of x into x minus mu by sigma equal to 0. So if you send that f of x to 0, that becomes 0. Now what you are having, x minus mu by sigma 0, and x minus mu equal to 0, x equal to mu. So now at x equal to mu, we need to find f double dash of x value. If we can show at x equal to mu f double dash of x is less than 0, then mu will be maximum value, which is more. So for that, we need to find f double dash of x. First I am writing what is f dash of x. So f dash of x is minus f of x into x minus mu by sigma square. So keeping 1 by sigma square as a constant, you are having f of x into x minus mu. This one we need to differentiate now. F double dash of x, 1 by sigma square, treating this one as uv, d by dx of uv, you know, d by dx of uv dash plus vu dash. Using that, what we can write? F of x into differentiation of x minus vu, differentiation of x1, plus x minus mu into differentiation of f of x f dash of x. Here minus is there. Minus 1 by sigma square f of x plus x minus mu into f dash of x we evaluated just now. F dash of x is this one, f dash of x value minus f of x into x minus mu by sigma. So minus f of x into x minus mu by sigma. So you can take f of x common. If you take f of x common, f of x by sigma square 1 plus x minus mu whole square by sigma. Here plus into minus minus, sorry. 1 minus x minus mu by sigma whole square. X minus mu whole square, sigma is there. Now this is f double dash of x. At x equal to mu, what is f double dash of mu? F double dash of x. Write in the place of x mu. If you write in the place of x mu, what happens? This becomes 0. Minus f of u by sigma square, which is clearly negative, which is less than 0. Which is less than 0, very clearly. So at x equal to mu, f of x has maximum value. So mode is equal to mu. What we proved now? Mean equal to median equal to mode. What we can conclude? In normal distribution, mean equal to median equal to mode. Clear?